Hi guys, today I'm going to be teaching you about PostgreSQL. PostgreSQL is a type of database. It's an open source database which is used for storing data about your applications or games or whatever. Today I'll be teaching you how to download and install Postgres, how to create a database, how to create a table, and how to interact with that table via select, update, insert, and delete. So let's go ahead and get started. Let's start by going to postgresql.com. .org, I apologize. It will auto-forward you if you type in .com. And let's start by just downloading it. So let's go to the download page. And I am on a Windows machine, so I'm going to download the Windows one. This does work on all platforms, as you can see, though. So I'm just going to download the installer. I'm on Windows 64-bit. And we're just going to go ahead and run this installer. Once the screen pops up, go ahead and click Next. And then it's going to ask you where you want to install your Postgres database. So I want it actually on my Z drive under Programs. Alright, and I'll go ahead and click Next here. It's going to ask you what you want installed here. I'm going to go ahead and check everything and then click Next. And Next here as well. And now this is the super user for your Postgres database. So Postgres ships with a default database. It's called the public schema. And it needs a username and password to get into this database. So the username is almost always Postgres. That's the default. And for this, I'm just going to put admin, A-D-M-I-N. I'm not going to use it for anything important, so that should be fine. But you can set this to whatever you want. Just make sure you don't forget it. And then the default port Postgres listens to is 5432. That's fine for this case. And default locale is fine as well. And this is going to go ahead and install Postgres on my computer. Perfect. Now that that's created and installed, we're going to go ahead and I'm not going to install additional tools, so I'm going to uncheck this box and I'm going to click Finish. Now that that's installed, you should be able to open Postgres by going into your search bar and typing pgadmin. pgadmin4 is what's going to pop up. This is the UI that ships with Postgres for interacting with your database. This does typically open in a browser or browser-like application. But this will actually allow us to spin up a database and interact with the data in that database. Once it finishes loading, this is what pops up. And this prompts you for the password that we just set earlier. So I'm just going to put admin in here because that's what I used as my password. Click OK. And now you're in the pgadmin tool. And mine does look different because I am using Dark Reader. So I'll turn this off so it looks more similar to what you're using. And go to Servers. And I don't want to save the password for this. And then once again, it's asking for that admin password so that I can get into this PostgreSQL server that it's set up by default. All right, once you've got your password in there, it's going to open up and it's going to show you this PostgreSQL 12. And you'll see that it's already got a database in here. This is that Postgres database that we were talking about earlier. But we actually want to create a new database for our use. So a common application I've seen for this is to-do applications. So if you're building like a to-do web UI with a to-do list of things you need to do, you can actually persist your data by storing it in a database. So that's what we're going to do in here. So if you right click on databases, you can create a new database, and we're just going to call this to-do list, or I'm just going to call it to-do. And this offers you a couple tabs here. So you can say who the owner is. So if you wanted to create a new user that's just for this database, you could do that. Or you could just use the default like I'm going to. You can select the encoding, character type, table space, security, parameters. And this actually displays the SQL it's going to run behind the scenes in order to create this database. So it's going to create a new database with the name of to-do, with the owner of Postgres, encoding of UTF-8, which is pretty standard, and a connection limit of -1, which means there can be any number of connections to this database. So if you only wanted one person to access your database at a time, you could change this to one. For this, since we're running it locally, there's only ever going to be one. So this is fine. So go ahead and click Save, and this is going to create that database for us automatically by running that SQL script. So once we have this, you'll see that there's a lot of fields in here, but we don't actually care about any of these except for the schemas. The schemas is where we're going to store our data. So once again, it creates a public schema with a bunch of extra stuff in here. We don't need to worry about this too much right now, but this holds a lot of Postgres data in the background. So go ahead and close this, and we're going to right click on schemas just like we did with the database, and we're going to create a new schema for our to-do list. So I'm just going to call it to-do. So this is the to-do schema in the to-do database. And I'm going to leave all the things as default again. And once again, it'll show you in the SQL tab the actual SQL script it's going to run behind the scenes in order to create this. So what this is saying is create a new schema, name it to-do, and give authorization to the schema to the Postgres user. That means only this user can interact with this database. You can always add more later, so this is fine for now. Now we have a schema of to-do, and if you expand this, there's once again a whole bunch of different fields in here. We don't care about most of these. Sequences are where you'll store like auto-incrementing numbers that identify a column uniquely, or any other kind of sequence you might need. Procedures are stored procedures or functions, which is basically a set of SQL code that can be run on demand to accomplish some sort of task. So go ahead and go to tables, and you'll see there's no tables in here. So if you right click on tables, go to create, we want to create a new table. And we're just going to call this table to-do list or to-do items. So we'll call this to-do items. We're going to leave it as Postgres. We want it in the to-do schema. So all this is fine. So go ahead and click on the columns tab. This is where we're going to define the actual columns that go in our database. So I like to always start my tables with a auto increment number. So this is a number that will automatically increment itself every time we add a new row to the table. So it'll start with 1 when we insert the first record, and then when we insert the second record, it will go to 2 and then to 3 and so on. So let's go ahead and add a new column by clicking this plus sign, and we're going to call this column ID because it's a unique ID for this row. And this is going to be a big serial. Now a serial is a special data type in Postgres that essentially means it's a big integer, but behind the scenes Postgres is going to go and create a sequence for this ID and assign its default value to be the next item in the sequence. So by selecting big serial, it's the same as selecting big int and then manually creating a sequence and setting the default value to the next value in the sequence. So let's go ahead and change this back to big serial. And I'm not going to worry about length, precision, or scale. I'm just going to make sure that it's set as primary key and not null. And so that's that column. We don't have to do anything else with that. It's going to do the rest on its own. So the next thing we need to put in here is a column for the task name. And this is going to be a text blob. So this can be any kind of task that we put in our to-do list, and we could put any kind of string in there that we want. A text is basically a free form field. You can insert anything you like in there. It does need to be not null. I'm going to require that you have a name for the task in my database, but that is obviously optional if you don't want to do that. The next column I want to make is actually a completed flag. So this is actually going to be a Boolean. So this is going to evaluate to either true or false. It's either done or it's not. This is also going to be not null. And I'm also going to do a created date. which is a timestamp, and a completed date, which is also a timestamp. And both of these are also going to be not null. So not null means you cannot insert a record into the database without providing this value. Now we're not going to have to worry about that because we're going to set up default values for a lot of these fields. But once we have that, let's go to the Advanced tab. And this is where we could set up like a relation to another table. So if our task ID was a relation to another table, for example, if we had two tables, one for our list of lists, so say we had more than one to-do list, like a grocery shopping list or a to-do list or a yard work list, we could then have another table called to-do list item, which has a relationship to the particular list that it belongs to. So all of our data would be stored in the to-do list item table, but it would hold a reference to the list that it belongs to. So each row would say, I am a member of the grocery list, or I am a member of the yard work list. So that's where we would define kind of a relationship like that. Constraints, this is where we would provide like a unique key. So say we had, say this was a users table and we had like a social security number on our table. Well, that's a unique identifier for a person, but we might not want to use that as our primary key for when we access our data. So we would mark it as a unique key by creating a constraint here. You can also set up foreign keys, which is another way to establish that relationship I just talked about between two different tables. There's the primary key as well, which we already know is going to be our ID column because it's an auto increment field that'll be unique for every row. Partitions we don't really need to worry about, nor do we need to worry about parameters. Security, so you can access who can read and write to the table. We don't need to worry about that either. And once again, the SQL column on this UI gives us the exact script that Postgres is going to run in the background to create the table that we just specified. So it's going to create a table in the to-do schema named to-do items. It's going to create the column ID, which is a big serial, which is not allowed to be null. It's going to create the column task name, which is a text field and also not allowed to be null. It's also going to create the completed field, which is a Boolean, which cannot be null, the created date, timestamp without time zone, which can't be null, the completed date without time zone, which can also not be null. And it's going to specify that the ID column that we referenced right here is going to be the primary key. Once it does that, it's going to alter the table so that the owner is set to Postgres. So Postgres user is going to be the administrator for this table, which is fine for our purposes. Go ahead and click save on here, and it's going to run this script in the background. And this will now display our table to do items in the dropdown over here. And if we expand it, it'll show us all the columns, which we just created. And if we want to see the data in our database, we can actually right click and go to View Edit Data, All Rows. And this will actually show the SQL it's going to run to pull the data, which is a select script, and the actual data in the table. So we see that there's actually no data in this table. So what we want to do is actually start putting data in here. Actually, there's more than one way to do this. So for example, if we just wanted to create a row right here, we could do that by typing, so if we click on our task name, we can type something in here like go grocery shopping. And click OK. And you'll see that this creates a row in the table but this is set to the default, this is set to null, this is set to null, this is set to null. And that's not really what we want. So what we want to do is actually specify the default values for these columns. So if we go over to our table on the left and we go to completed, we go to properties, and you'll see that there's a tab here for constraints, and default is one of the options here. So the default we want for this column is false, because when you create a new to-do item, it's probably not done already. So let's go ahead and save this, and we're going to do the same thing for created date. We're going to go to constraints, and we actually want to call a built-in function from Postgres called now. So we click save. We want this one to be nullable. So let's actually go to properties for completed date. We'll go to constraints, and we're going to mark it as nullable. So we uncheck this box for not null and click save. So to save data, once you actually manually edit it like this, all you have to do is actually press F6 on your keyboard. So just to demonstrate, I'll do it again. So let's add another to-do item like walk the dog. And we'll add this here. And you'll see that at first it says the default value will go into the ID column, default will go into completed, and default will go into created date. And completed date will be set to null. So in order to save this in the database so it's actually reflected, because if I don't save this and I go to to-do and go to view edit data, all rows, you'll see that that row goes away. I didn't save it. So we'll put it back in here, walk the dog, and click OK. And to save this, I'll press F6, and you'll see it automatically populates my serial with the next number, and it puts the default value in these other columns. So that's how you save data via the UI. But now I'm going to show you how to do the same thing using the query tool. So at the top here, we have this thing called the query tool. If you click on this button, it's going to give you a blank page where you can write SQL. So what we want to do is actually write an insert statement into our table. So let's back up a little bit. Say we want to write into our table, but we don't know how to do that. If you go to your table and you right click on it, you can go to scripts, insert script, and this will create a basic script for you to use. So I'm just going to copy this. I'm going to put it in the query tool. And what this says is I want to insert into this table. So I want to insert records, because if you look at the database, each one of these is called a record. So a horizontal line here with a list of values, this is called a record in a database. So I want to insert records into this table, the to-do items, inside the to-do schema, and these are the columns that I want to put in this table. So I want to give you these columns. You can use double dashes like this to signify a comment. So this actually won't be executed. It ignores this line because of these double dashes. So it says, I want to insert into this table. These are the columns that I want to provide you. And these are the records I want you to create. So we don't actually need to provide all of these because these are all provided for us via our default values that we set up. So the only thing we actually need to give for our table is the task name, because we set up the default value for the ID because it's a serial. We set up the default value for the completed because it's false when it starts. And we set the default value for the created date because we're creating it right now. So the only thing we need to give is the task name. We don't need to give the completed date because we said that it's allowed to be null. So we want to insert records into the to-do table, or the to-do schema into the to-do items table, and the values we want to give are the strings that we want to put in the task name. So we only want to give the task name as the column, and this is the value we want to go in that column. So we'll say another task is mow the lawn. And if we run this by clicking the run button here at the top, this will say the query returned successfully in 42 milliseconds. So if we go back to this other tab at the top, we can refresh our data by running this select SQL again to see what's in there. So you can click the button and it will say, oh, there's a new record called mow the lawn. We can also do that in our query tool by creating a new query and say select star, which means select everything, from the to-do schema dot to-do items table, semicolon. So you can click the play button to run this, or F5, and it will run. So it looks like this F5 button, clicking this, will run everything in the query editor. So if I only want to run this table, this one line, I have to highlight it and click this button. So now you'll see that it only does the one line instead of running both of these. So this is the same functionally as this here. So this is giving order by ID, and the one we wrote is actually just returning it in the default order, which is the same thing. So it's sorting by this ID primary key and giving them to us in order. We could also change this to order by created date, or whether it's completed or anything we wanted. So now we know how to create a table, we know how to write into our table, and we know how to read from our table. What we still need to do is know how to update and delete things from our table. So you'll see when I accidentally ran this script a second ago and I created the second row of mow the lawn, this is functionally identical to the previous row. And we don't need two of them. So we're actually going to delete one. So I'm going to create a new script here, and I'm just going to delete that row. So delete from our schema of to-do items, where ID is equal to 4. So this is going to run through every single column or every single row in our database, and anytime it finds an ID that is equal to 4, it's going to delete the row. You can also do this where the task name is equal to that string of mow the lawn. This will delete both rows. So functionally, this would be the same as saying delete where ID is equal to 3 or 4. ID is in 3 or 4. So you can provide a list of things if you use the in keyword instead of the equal keyword. For our purposes, we only want to delete the 4th row. So if we run just this script here, we'll say it deleted one row and it returned successfully in 34 milliseconds. So now we want to run the select one again, and we'll see that we no longer have a 4th row. But if we insert a new row, so say we go back to our top one here, and we want to insert a few more rows, we can actually insert more than one row using an insert statement. So instead of putting a semicolon here, we can give it another record. So we can insert more than one record by providing more than one value. So we want a new to-do item of create a tutorial, and another one of create an API, which stands for application interface. If we run this now, we'll see that it adds 2 rows to our database. So this is throwing an error because I didn't put a comma between my 2 records. So now if I run this, it will create the 2 rows. So you see it says insert 2 rows, and it's completed successfully in 42 milliseconds. So if we run our select now, you'll see we actually have 5 rows, but it skipped number 4. Now this is because we already created the serial ID of 4, and then we deleted it. So we had already incremented our sequence in our table to 4, and then we deleted it. And when our database asked for the next value in the sequence responded with 5 because we had already done 4. Now that is perfectly fine. It might be a little annoying if you've got OCD because obviously the numbers are out of order, but these numbers are going to be obfuscated from the users. They're never going to see them. They're only going to be used to access the data behind the scenes. So it doesn't matter if they're actually in sequential order or if we're missing things. And it's normal for things to get deleted in a database as well, because once we've deleted this to-do list, we don't need these items anymore, right? If we've completed everything on it and we want to delete the list, then we don't need to store this data anymore. But it doesn't matter if our numbers keep incrementing. We don't need to restart it because that would actually invalidate some of our existing data. So we can create multiple rows with an insert statement. We can select from our database with a select statement. And if we only wanted to select a certain column, so say we only wanted our task names from our database, we can run this and specify the exact column or series of columns that we wanted. So say we just want to know the task name and if it's completed, we can actually run this select statement and get just those 2 columns. And now we don't have to worry about the ID column anymore. It's not visible to us. So now we know how to delete from our table, but now we also want to be able to update it as well, right? So let's go ahead and select star again so we can see everything in our table. And I'm going to delete this because I don't want to accidentally run it again. And I don't want to run this one either. So if we wanted to update our table, so say we've just completed our task, we now need to mark it as completed. So we need to update our table, so to-do dot to-do items, and we want to set the value of the columns. So we want to set completed equals to true, and we want to set completed date equal to now, which once again is a Postgres function to get the date of right now. So it collects the current timestamp and then it will store that in the database as our completed date because we've specified it as the value. Where ID equals 2. Let's say we just finished walking the dog. So we can run this statement and it's going to update this row where ID equals 2. It's going to set completed to true, and it's going to set the completed date to our new timestamp. So let's run this, and then run our select again. And you'll see that 2, walk the dog, is now true, and it has a completed date. So if we select the in order like we are in the other screen, so order by ID, we should now see it in the same order as before, but with walk the dog true. So that is how you update a record in a database. So now we know how to insert, we know how to update, we know how to delete, and we know how to select or read from our database. And you can get templates for all of these scripts on your database by clicking on a table, going to scripts, and generating a select, update, insert, delete, or create script. Remember, create is used to create a new table. And you now know how to create and use a Postgres database on your local machine. If you like this video, please like and subscribe. If you learned something, please let me know in the comments down below. And if you want to learn about something else, don't be afraid to ask. I'd love to make a video on it. Thanks.